Welcome back. Problem 7-22 says statement is determine the shear stress at point B on the web of cantilever strut at section AA. So you can see this is a cantilever beam that is acted upon by a 4 kilonewton point load at the start, and then at a distance of 300 millimeter there is a 2 kilonewton load. So cross section of this beam is given as inverted T beam. Clear? So you have to find the shearing stress at the on point B that is shown over here on the web of cantilever strut. So let's start with the solution. So as we know that maximum shearing stress or shear stress is equal to V into Q divided by I into T. So we will need shear stress, we'll need first moment of inertia about neutral axis, we need I, we need T. So how we will find this V? So for that, if you remove this support at the end of cantilever beam, so definitely you will be having a reaction force RA, and there will be a moment that is MA. So we will find this reaction force and moment by using equilibrium condition that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you have RA which is acting upward minus this 2 kilonewton minus this 4 kilonewton is equal to 0. So from here you will get this RA will be equal to 6 kilonewton. Now you can also find the moment that is not required, but we will find sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A we have one moment MA that is counterclockwise, so it will be positive, plus the second moment is due to 2 kilonewton load and perpendicular distance is this one which is equal to 500 millimeter. So minus 2 into 500 because this is producing clockwise movement. The third moment is due to 4 kilonewton and perpendicular distance is now 500 800. So minus 4 into 800 is equal to 0. So when you solve this you will get moment about point A comes out to be 4200 kilonewton into millimeter, or in term of meter this is equal to 4.2 kilonewton into meter. Now you have this moment as well. So maximum shear force can be obtained by shear force diagram. So we will draw the shear force diagram. So for that you have to take the vertical lines from the end of this beam and then a horizontal line to show the length x in millimeters. So here you will draw the shear force that will be in kilonewton. Okay, so let each division is of 2, so 2 6 4 kilonewton and 6 kilonewton. Clear? So at point A you can see you have RA which is equal to 6 kilonewton. So your first point will be this one. Now moving from point A till this load, there is no other load between this them. So it will be horizontal till this 6 kilonewton. Now here you have a 2 kilonewton. So 6 minus 2 will bring it to 4. So it will come to 4 kilonewton. Again moving from this to, and there is no other force, so it will remain horizontal, and then at the end you can see minus 4, so which will bring it to downward 0. So maximum shearing stress from this shearing force from this shear force diagrams comes out to be 6 kilonewton. So we have done with this V. Now we will find I, and for this inverted T beam you can see we do not know its neutral axis because this is not symmetrical about its horizontal axis. So we will first find its neutral axis. So formula for finding the neutral axis is y bar is equal to sum of y dash into A divided by sum of area. So you can see you have two portion, one is this one and the other one is this one. So first area of this portion is 0.05. I have drawn this cross section and all the values are converted into meters. So first area is 0.05 into 0.02. So 0.05 into 0.02, and y dash is distance from the base, because we have taken this base as a reference. So this is y1 dash, and this y1 dash is 0.02 divided by 2, which is equal to 0.01, plus now this second one, so its area is 0.02 into 0.07. So 0.02 into 0.07, and what will be its centroid of this second from the base? This is equal to y2 dash. Okay, this is y2 dash, and this y2 dash is equal to 0.02 plus 0.07 divided by 2, which gives you 0.055. The half of 0.07 plus 0.02 will give you y2. Divide by sum of all area, which is area of 1, and area of 1 was 0.05 into 0.02 plus the area of 2, which is 0.07 into 0.02. So when you solve this, you will get the location of neutral axis from the base comes out to be 0.03625 meter. So it means that y2 y dash is this one. This is your y dash, distance from neutral axis, from the base till neutral axis. This is y dash. Now we have y dash, so we will find I by using parallel axis theorem. So that is equal to sum of I plus E d square. Clear? For this one, this area is this moment of inertia is equal to 1/12 its base, which is 0.05, and its height, which is 0.02 whole cube, plus area, which is 0.05 into 0.02, and d square. D square is distance from neutral axis till mid of this. So this is d1. So d1 is, you can see d1 is equal to y dash minus y1. So y is 0.03625 minus y1 dash is 0.01, and its square, plus the moment of inertia of second, which is 1/12. Its breadth is 0.02 and height is 0.07. So 0.02 into 0.07 whole cube plus area, which is 0.02 into 0.07, and d square. So d square for 2 is this one. This is d2. Distance from neutral axis till mid of this section. And this d2 is, you can see, equal to y2 dash minus y. Clear? That will give you, so y2 dash is actually 0.055 minus y is 0.03625 whole square. So when you calculate it, you will get the moment of inertia of this inverted T beam comes out to be 1.78625 into 10 raised to power minus 6 meter 4. So this is I. Now we will find Q. So we know that Q is equal to y dash into A. So for this portion, I will choose blue color. For this portion, you will find Q, and you know that this Q is equal to this area, which is 0.05 into this. So area is 0.05 into height 0.02. And what about y dash? So y dash is this distance from the neutral axis. So this from from neutral axis till this distance, and this distance is again equal to uh, y minus y dash minus y1 dash y1 dash, this, and that is equal to y is 0.03625 minus y1 is 0.01. So when you solve this, you will get this will equal to qb, and that qb comes out to be 26.25 into 10 to the power minus 6 cubic meter. Now you have all the values, you can just put it in the formula. Shearing stress at point B is equal to V max into QB divided by I into T. So V max from the shear force diagram is 6 kilonewton. So I will write 6 kilonewton. So 6 into 10 to the power 3 multiplied by QB is 26.25 into 10 to the power minus 6 divided by I is 1.78625 into 10 to the power minus 6, and T is this thickness which is 0.02. So again, when you solve this, you will get the maximum shearing stress at an inverted T beam at point B comes out to be 4.41 megapascal. And this is answer of our this question, and that was all about problem 7-22. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.